All right, so for this one, it says a 4 kilogram block sliding on a frictionless surface is moving with an initial velocity of 9 meters per second. The impulse is applied to the block and is shown on the graph. Okay, so this is a force over time. What is the block speed at time at 6 seconds? All right, so the change in velocity due to the impulse. In other words, let's look at this. Force over time. That's impulse, right? Well, that's equal to the mass of the object. And so, well, let me show you some stuff here. So think of this like this. Newton's second law is that force is equal to mass times acceleration, right? Well, really, that's the change in velocity over the change in time, right? So we could say delta V over delta T, right? Well, now if I take force and I multiply it by delta T, then that's really this stuff, delta V over delta T times delta T, right? Well, that cancels out, and so force times delta T is really just the mass times the velocity. So that's where you get momentum is equal to the force times time, right? So then if I take this equation, so that's where that relationship comes from. Now, we just wrote it down in our notes. I just wanted to show you where it came from. So if I solve for velocity, because that's what it's asking for is the velocity. If I take this equation and I divide this by the mass and I divide this by the mass, right? I get that force delta T over the mass is equal to the velocity. You guys with me so far? Well, I know the mass, right? I know the time. I can figure out the initial velocity is 9, right? How do I figure this out? Well, what is the formula for impulse? Does anybody remember the formula for impulse? Impulse is equal to what? Look in your notes. Yeah, that's another, there's one way to, F average, or what else? Well, how is it written down? Yeah, so it's the force times delta T. Okay. Well, can I get that from here? So what is the force that's being applied? Well, I have a force that's equal to 8 over time, which is 2, but the average is in the middle, right? But Does this peak? No. We're just going to leave it at 16. So really what we have, we could use this time or not use this time. But if I calculate the impulse at 16, I have 16 divided by the mass of the object, which is 4 kilograms. So I have 16, right, Newton seconds, because this is in seconds, this is in newtons. 16 Newton seconds divided by 4 kilograms, which is my velocity, which is equal to 4 meters per second. Right? Does that make sense so far? So then what is so my final velocity after the impulse? Well, what was the initial velocity? Oh, that was 9 meters per second, right? And then we added 4 more meters per second. So the total is 9 plus 4, which is 13 meters per second. And so it's kind of hard based on this, but imagine something moving at 9 meters per second and then something coming along with a velocity of 4 meters per second and colliding into that. Well, if it collided into it for 2 seconds, the impulse would be 16 Newton seconds, and that would increase the velocity by 4. So your 9 plus 4 gives you the 13. So this is technically the answer. I don't know if that made sense to you guys or not.